Hello. How is everybody doing? Woo! That was like, I need to hear more from you guys. How is everybody doing? Hey. So, okay. That's all I wanted to do. It's nice to see you. Nope. So I am really passionate about the topic that Alessandro is going to talk about, which is relevance evaluation and open source tooling around that. Last year, as Max said, I talked a lot about plungers. So it's like the inside joke. By the way, about a week ago, I actually searched on Amazon and purchased a plunger. And I saved the screenshot of me purchasing that plunger. I forgot to tweet it out. But I thought that was just fortuitous, of course. Relevance evaluation has been a short-term or a long-term passion of mine. And I would not have gotten into relevance if it had not been for having to come up at the last minute with some crazy hacky way of evaluating relevance. A couple of years ago, John Berryman and I sat in an office not too far from here. And while he was trying to solve the problem, I was busy coding some way of measuring the problem because that didn't exist. And I often tell people that relevance measurement, people often jump to machine learning and all of these other fancy solutions as sort of the silver bullet for this stuff. But to me, and I think to other people, relevance measurement is really the silver bullet for this stuff and getting a systematic methodological way of doing relevance measurement. And I'm just so happy that Alessandro and Andreas at CEAS have taken the passion of open source in information retrieval and turned it into a really interesting product. Alessandro is a search consultant at CEAS, focusing on information retrieval, NLP, machine learning. And he loves to work on search machine learning projects. He's an active open source contributor, and he speaks a lot at conferences like ECIR, Lucene Revolution, Past Haystacks, Haystack Europe, ApacheCon, all the great open source conferences. So without further ado, I'll turn it over to Alessandro. Thank you.
Thank you. Thank you, Doug. So first of all, I'm honored to be here and be the first speaker in this session. So thank you, Open Source Connection, for giving me this opportunity. So today I'm going to talk about Rated Ranking Evaluator, which is an open source approach for search quality evaluation. And open source here is actually related not only to the approach in evaluating search, but also of the target of evaluation. So we're going to talk on how you can evaluate open source search solutions. So as you can see from here, I'm a software engineer working in CEAS, software engineer and director actually, but director is the side work. So my main interest is software engineering, as Doug already mentioned, and I'm very passionate about search. Andrea is my colleague. He didn't make it for the conference, but he actively worked a lot on the matter I'm going to present. So brief introduction about myself, already been done, so we can skip the slide. Only thing to add is that apart from everything related to search technologies and machine learning, I'm very passionate also about beach volleyball and snowboarding, which I can't do in London now, but I do it in Italy when I go back because I'm originally from Italy, and snowboarding during winter time. Andrea, my colleague, has been a software engineer from 1999, and he calls himself hermit software engineer because he usually works from home in a small village in Italy. And he's very passionate about Java and information retrieval. And music, actually. He's also a bass player. So, very quick slide about my company. So we are open source enthusiasts, and we are Apache Lucene and Solar experts. We work also with Elasticsearch, but our main expertise is in Apache Lucene and Solar. And we are very active in contributing back to the community. So we strongly believe that open source is the way we, software engineers, can help improving the world in our little. And so apart from working from customers and of course getting the way to survive, we are very happy to contribute to the human community and try to bring something, to give something back So we are active in the Solar mailing list. We have been actively contributing to the Apache Lucene and Solar projects. Apart from that, we are active researchers, so we like challenging problems, and we are very active in trying to solve new problems. And currently, the hot trends in general for information retrieval, but specifically for our projects, is learning to rank, document similarity, search quality evaluation, which is in bold in here because we are going to talk about that, and relevancy tuning. And this is a list of the customers that contribute to our works. So, search quality evaluation. We are going to give a context overview to introduce yourselves to the problem. And then we're going to see Rated Ranking Evaluator, which is an open source approach to solve the problem. So, evaluating search quality is not an easy task. As Max already introduced in the keynote, it's very difficult to understand, first of all, how good the system is and what good means. So that strictly depends on the stakeholder and who is assessing the quality of a system. So the business side could be interested in like a certain amount of factors, and the software engineers may be interested in others. So correctness and effectiveness is, of course, a very important factor in evaluating the quality of your system. So, but it's not the only one. So a system to be good must to be extendable, maintainable, efficient, and robust. And this is what the business sees. But of course, software engineers are focused on a lot of other factors. So modularity. So you want your system to be modular. You want it easy to be extended and tested. And you want to be able to extend your system, improve your system, and measure the kind of improvement you made or regression. So because of that, you need multiple metrics to evaluate your system. So let's focus on correctness or effectiveness in information retrieval. So how good your system is in performing its task. So we talked about relevance before in the keynote, and it's about relevance. So is your system able to satisfy the information retrieval task, making the user happy of the results? And why this is important? This is important because in the software engineer life, you're going to work in normally an iterative way. So after each iteration, after each deliverable, after each release, you want to see how good is your system, if you made some improvement, if you made regressions. And we are not talking only about like functional, so like you can do unit testing, integration testing, but then measuring like the search relevance is not that easy. And you need some tool and some approach to perform that. So in here, you can see like different kind of use cases for that. So you have your stakeholders, you have your product owner, and then you have different iterations. You may work in an agile environment, you may have the sprints based on like a small period of time, and every time you finish a sprint, you want to contribute an improvement to the system, and you want to be able to show that to yourself, to the team, and to the business. So what do you need to do that? So first of all, you need the ground truth. So as we've seen in the previous talk, it's not easy at all to have a ground truth. In here, I simplify a little bit what we've seen already in the previous keynote, but there are mainly two possible ways of gathering ratings and relevancy ratings for your search system. So you may have an explicit feedback, and that is going to be from a domain expert group or a crowd commission, like for example, to an external mechanical Turk system, for example. And this means that the user, the raters, needs to assess how good a document is given an information need, in this case, a query. This explicit feedback, of course, is not easy to gather, is expensive, and potentially you may have disagreement as we've seen. So sometimes you may need to rely on implicit feedback. So as we've seen from this slide, you have a query which is Queen music, and you may have different documents, like a Queen album document, a document talking about a movie, and an e-commerce element like a dancing Elizabeth Queen, which is not very relevant for the kind of user intent in this request. And in moving to implicit feedback, you can measure that rating, that relevancy through, for example, the user clicks or other signals, other user interactions, such as adding to the cart or sales, for example. So that's the first thing. So you need to gather a ground truth. If you don't have a ground truth, you cannot proceed with evaluating your system. But after that, you need to understand how to measure the quality of your system. So for this, you may have a mathematical modeling of how good your system is. So you will have a lot of different metrics implemented for satisfying different kind of aspects of quality, of search quality. So let's make a distinction here. You may have offline measures which don't relate to the real production system performance, and online measures that are measured on a live system and show the effective user engagement. So you may imagine that the offline measurement is based on some sort of experience disconnected from the live system, potentially information gathered from previous sessions of your live system, but anyway taken offline, and online are effectively showing how the system is currently performing. We can have some of the metrics listed in here. Some of them are very popular, some of them less. We've seen NDCG already, and probably most of you are familiar with online measures such as click-through rate, session abandonment rate, and zero result rate. So all of them measure a different aspect of your live system. So out of impressions, so out of how many documents you show, how many of them are actually clicked, how users are engaging with the system. So are they actually leaving after a few query reformulations, or they immediately get the results, for example, and they're happy. So let's see how evaluating a general system works, and then we'll see the equivalent in the open source, in an open source environment. So the evaluation starts from an input, the input we've seen. So you need the information need defined with the associated ratings. That's the ground truth. Then you need to focus on a metric, one or multiple metrics that are going to measure how good the search quality is regarding to the ratings you collected. At that point, you can evaluate a system that will have a specific status. So of course, when you evaluate a system, it will have a corpus of information, which is the data you are searching in. It's very important also to consider the reproducibility of a search quality evaluation. So you are expected to have the same metric score, keeping locked the input and the system. So this is very important because you want to keep track of the quality of your system. You want to know in the future what was the quality in the past, and you want to be able to reproduce a certain status. So let's see how you can do that in an open source environment. And specifically, I'm talking about RRE, which stands for Rated Ranking Evaluator. So first of all, open source search engines. So RRE is built to work with Apache Solr and Elasticsearch. We don't have to explain here what Solr or Elasticsearch are, but both of them are based on Lucene. So this is the main factor in RRE. It's basically built to evaluate Lucene-based search engines. So first of all, what is a search system status in an open source search system? The data, so the documents in input, and index time configuration first. So how does your indexing application pipeline looks? So how are the documents processed? How is the update processing chain defined? For example, if you're using Apache Solr, you can define a chain of update request processors that can take an input your documents and do transformations. So adding fields, removing fields, changing the value of fields, for example. Where a document you can have, probably most of you have an idea of what a Lucene document is, a Solr document or Elasticsearch document is. You can imagine they are just a map, key, value, values, because it can be multi-value. So the update processing chain may actually change the way the document looks before it is finally indexed. So the last component that affects the corpus of information at indexing time is the text analysis configuration. If you change the text analysis configuration, you're going to have a completely different inverted index potentially, and that means that your system will behave completely different also from a search quality evaluation perspective. So in this example, you see 3 documents, an example of stop word list, and an inverted index that is built. So Apache Lucene works, the way Apache Lucene works is based on an inverted index, and this is the same approach that is used by Apache Solr and Elasticsearch, because they both rely on the same library internally. And this is indexing side. Also, we need to take attention to the system status at query time. So if you want to reproduce a system, and if you want to evaluate a system, there is one factor that is on top of the indexing analysis, which is the query time. So how your search API builds your queries. So effectively, it's likely you are going to have an intermediate layer that will build your user query. So from the user interface queries, build the queries that are going to be sent to Solr or Elasticsearch. And then you need also the query time configuration. So if you want to evaluate a system and if you want to have an open source search system status fixed, you need to be completely aware of your query time configurations, which specifically may be the query parsing, for example. So as we can see in here, you may have a query like the white tiger. You send the query from the user interface to your search API. Then the search API builds your nice Apache Solr query, for example, adding some boosting by popularity field and adding like specific query fields to be searched in with a boost, for example. And then in your Solr server, you will have your query parser that takes the query input and builds the Apache Lucene query. All of these factors are very important because if you change the search API, if you change your query time configuration, you invalidate a past search quality evaluation because you may have completely different behavior. So, rated ranking evaluator. So what is it? First of all, it's an open source search project developed by our company and contributed back to the community. That is, at the moment, a set of search quality evaluation tools. So you may imagine it as a sort of framework that allow you to evaluate your Apache Lucene-based search system. And it is currently compatible with both Elasticsearch and Apache Solr. And it can be also used in non-Java projects because it's currently possible to operate it through command line interface through Maven. It's currently licensed under Apache 2.0 license and is open to contribution. So we are very happy seeing like a lot of people contributing from Open Source Connection, for example, and is open. So please feel free to contribute. So this is an overview of the RRE ecosystem. So the most important part is the core library. So that's where effectively you will see the metrics implementation and the retrieval of results from the spinning up of your search system, query of the search system, and then assess the quality and calculating the metrics. But then you have like the Elasticsearch and Apache Solr Maven plugin. You may have the RRE command line interface that effectively is possible through Maven. And then you have the RRE Angular dashboard that allow you to explore a little bit better the results. And then in the future, we're going to have like additional plugins, such as for Gradle, the equivalent we have currently for Maven. And why not? Jenkins, Bamboo plugins, everything that helps continuous integration, for example. So we've seen how evaluation generally works in a search system, but let's now go to the details of open source search systems, and specifically using RRE to evaluate the system. So the input, we've seen the input before. We need ratings that are associated to information needs, and you need to specify metrics. So in RRE, ratings are currently expressed in JSON. So you will have the information need with the related annotated documents. And we support a list of metrics, so you can select the metrics of your interest. Then you evaluate an Apache Solr and Elasticsearch system that has a specific system status. So first of all, the Apache Solr and Elasticsearch version. So of course, if you change the search engine version, you are invalidating the previous assessment, so you need to evaluate it again. And then you will have data in index time configuration and query building and query time configuration. If you keep locked the input and your search system status, you want to expect the same metric score. So you want that to be reproducible. So let's see how RRE define the information need domain model and the ratings associated. So it's based on a JSON representation, so it's by nature hierarchical, and you have like optional nodes. So you will have mandatory nodes, which are the one in green. So when you define your information need and your ratings, you need to define the corpus, so the collection of data. Effectively, it maps to the Solr collection concept. Then, if you are able to group your information needs under different topics, you may express the topic as a nested level, and query groups. So when you have like different queries that are expected to return the same results, you are effectively having a query group. So you may associate to that query group a list of documents that are going to be shared among all the queries belonging to that group. And then you have the query, of course. So the final information needs. So the fine-grained information needs. So at this point, you may enrich a query with topic or query group, but in the end, you are associating documents with the rating to your information need, which is the query. So how do you express that? We have in here the JSON representation. You find it specifically on the wiki of the project, so we don't need to go through all the details of this JSON. The only important thing is that it is currently hierarchical, and you will have leaves the relevant documents with a specific rating associated. So currently, two ways of describing the relevant documents are supported. So you may express the ID of the document and the gain, which is the relevance rating, or you may map from the relevant rating the list of all the documents ID which share the same rating. So we've seen how you can define the ground truth in RRE. Let's take a look to the available metrics. So currently, we support a set of metrics. It's not important to describe each of them, but you can see like various kind of precision depending on the top K elements you want to measure. NDCG, which is again quite well spread in the industry. A lot of people use it, and also NDCG can be calculated at K, so in relation to the top K documents. And so in here, you will find a lot of metrics. You may find the metrics you are looking for. If you don't, absolutely happy to see contribution in that. For example, we are working also on some diversification metrics, because sometimes, apart from calculating like how good your content is, you may want to see how diverse it is. So is it covering all the possible choices you want to offer to your customers or to your user, actually? So we've explored the input. So it's clear how you define the RRE ratings. It's clear how you define the ground truth and how you can model this information. Then you have your system. So to evaluate your system, you need to be able to tell RRE to reproduce the status. So the first initial approach we implemented was the embedded approach. So RRE was taking in input a system status defined by the index time and query time configuration, spinning up an embedded search system, and then using it to evaluate it. An alternative approach, which is currently available and we are working on to improve it, is actually to point to an external server. So, for example, you may have your QA server that you're using continuous integration, and you want, every time you make a release, you want to check and you want to assess the quality of your QA environment. So you don't want to spin up a new search instance. You have already your QA instance, you have your data, you have your configuration, and you have your search API already in place. So you may want to use that. So when spinning up your search system embedded in RRE, you need the index and query time configuration. So RRE offers you the possibility of defining the files that defines the index and query time configuration in Apache Solr or Elasticsearch, basically grouped under a specific version. So you may have your version, hopefully under source control, and you are able to pass that to RRE. So it will be able to spin up the search server with your exact configuration. And then you need the corpus of information. So if you are spinning up the server internally in RRE, you need to populate it. So if you're using your QA instance, it may be already populated, so you don't need anything else. But if you are spinning up your search server, you need to add the data as well, and the same data that have been associated to the information needs and ratings. So in case you change your data, you may need to change your ratings and your information needs. Then RRE allows you to define the query templates. So effectively abstracting the logic that you may have defined in your search API. So currently we are also working on ways to bypass this. So for example, you don't want the RRE administrator to define again the way you build your queries, but you may want to be able to fetch them automatically from search logs, for example, of your Elasticsearch or Solr instance. And then you're able to get the metric score. So we've seen the input layer where you specify the data, the index time and query time configuration, and the ratings. Then you have the evaluation layer where you have RRE with its library and its components, and the spinning up of an embedded search instance. And then you have the output layer, which will show you the results in different formats. So like JSON format, which is the native way RRE return results, or through the RRE console that show you, for example, in a little bit more graphical way how good your system is. Other options are like PDF reports or Excel reports, or you may want to persist this information in Solr and Elasticsearch again, and then make use of advanced analytics to explore your evaluation results. So how does an evaluation process effectively work? So first of all, RRE will start the search platform, so we'll init the system, we'll create and configure the index, populate with the data, and at that point, we'll scan all the information needs with the associated ratings, execute the queries, retrieve the results, compute the metric. And this will be repeated across all the information need defined, so among all the queries defined. In the end, it will stop the platform and output the evaluation results. The evaluation output will be very similar to the rating format. So natively, it's going to be a JSON with hierarchical information. So you may be able to explore the evaluation output at different levels. So you may want to explore it at topic level, at collection level, or you can go down to each query, group or each query. So this is just like an example of the Excel output format, and it may be a little bit intense to be explored if you have like various versions, for example, if you are comparing various versions of your system. And then you have like the RRE console, which currently is the nicest way to explore the output data. So this was built for the software engineer and the business, but initially it was developed with the software engineer day-by-day work in mind. So you may want to evaluate the quality of your system, do some tuning, some new development, and then be able to assess if what you've done is actually reflecting to quality improvements or not. And I mentioned initially was for the software engineer, but effectively is not the only stakeholder that wants to use RRE, because you may want, for example, as a product owner, to see after your sprint ending if the development has produced effective benefits to your system. So what you are currently working on is a set of problems, such as, do we have to write all judgment manually? So effectively, it's very unlikely that a company or a user will just provide manual JSON with all the ratings associated to the information needs. So we are currently working in automating this through user interaction collection or exposing a user interface that will, for example, allow the user to rate given an information need and the document a specific rating, in a way that the JSON will be built, but the final user of RRE will not see the JSON format. Another aspect we are currently working on is the query time definition for your system status. So you may have like Search API building very complex queries. You don't want to redefine them. It's very error prone anyway to redefine the logic just for RRE. So we are currently working on ways to be able to extract the logic from the Search API without actually having the user to open their Search API code. And what about persisting the evaluation data? So of course that is quite important, and we are working on that direction for giving the user a possibility of exploring the data in a way that it's actually easy, both from the business to have a quick overview and from like software engineers to explore in deep and compare in deep different versions. So I put in here all the resources, so such as the current GitHub repository we are using for RRE, a blog article written by Andrea, my colleague, and then a demo project we've been presenting at FOSDEM last February in Brussels, and is available for anyone to take a look and play a little bit with the projects. So in the last 10 minutes, more or less, we are going to explore a little bit the demo and see how it looks like. So I hope it's readable, more or less. It's actually what I want to show is the expected configuration and system status format you need to pass to RRE for the configuration sets definition, corpora, ratings, and query templates. And then we can see how you can then specify in the POM, for example, to evaluate your system for different metrics in here defined and different versions. So the configuration, as we've seen before, we need to specify how your system is configured. So you have in here the different configuration sets for different versions. So you will have version 1 till version 1.6. Each of them will have a specific configuration for Elasticsearch to specifically, for example, do nothing or applying a specific text analysis. So it's very simple demo, just to give you an idea of how you can use RRE. This demo is going to be based on relevant search book examples So you can take a look on the GitHub repo, and at this point is not important that the kind of configuration applied and the problem solved across the iteration, but it's most important actually to take a look how you can evaluate the different versions and how do they look in RRE. So when you will take a look to the configuration settings here, you will see like different text analysis, and different query templates, for example, that will apply to the different example of information needs. Then you have the corpora, which is going to just be a movie database example, and the ratings associated. So for the ratings also, it's just very few ratings associated, just to show how you can then evaluate them and to show out the JSON syntax of how you can define the ratings. And the same for the templates. So in here you will have like how the queries are built. So the fields are affected, various kind of queries supported by this demo, and you can play through that and change them. So from the POM, in the demo, you can specify the versions you want to compare. So for example, you may be interested in comparing the version 1.0 and the version 1.1. And when comparing those two versions, you may be interested in these four metrics, so like the precision at 1, the precision at 10, the average precision, and DCG at 10. So then the only thing you need to do is you proceed just in installing your Maven archetype. Locally, RNA will start up. In this case, in this example, is going to be an Elasticsearch embedded instance. It can be a Solr instance as well. So as we can see from here, from the logs, you see that an embedded Elasticsearch instance is going to be started, has been successfully started, one rating set is found, which is the one defined in the demo, and one index is found, which is the one related to the movie database. Then the data is populated in the embedded Elasticsearch instance, and the configuration as well. At this point, as you can see from the hierarchical representation in here, a specific query is going to be executed from all the query groups and the topics defined. So like from Space Jam, for example, and the query group like related relevant search book chapter 3, and the query basketball with cartoon aliens. And then other queries from Star Trek topic and related like actors and roles in the movies. Then as soon as the Elasticsearch evaluation is completed, it's preparing for shutdown. So the embedded instance will be shut down, and you will get the results in the dashboard. So when at the moment, when evaluating the results from the dashboard, you can see the score for the different versions and the different metrics. So we define 4 metrics here. So each column is a metric, and within each metric you see a different column for the different versions you are comparing and the delta. So in comparison to the previous version, how is the metric currently compared? So do we get like a benefit, an improvement, or a regression, for example? And in case then the software engineer wants to explore it, you can even go through to the details. So what are the list of documents that were matching the basketball with cartoon aliens query in version 1 and in version 1.1. And in this example, all of them are not relevant in both of the iterations, so version 1 and version 1.1. For the Star Trek query, we can see slightly different behavior, because in the first query, in the version 1.0, we had the position of the relevant documents slightly slightly different. So the relevant documents moved up a bit, and that brought an improvement in NDCG at 10, as we can see from the diagram here and the results in here. Then, for example, you may be interested in changing the comparison, and we could, for example, compare the first version with the 1.6 version and see how we improved from the original version through the last iteration of our development cycle. So we may just have this integrated with our continuous integration system, for example. So in addition to unit testing, in addition to integration testing, we may have the layer talking with RRE that will also check the quality search behavior. So are we having regressions? So being a demo, we built like a lot of artificial improvements. We didn't know from the beginning the problem, so in each iteration we solved some of the problem through configuration of the Elasticsearch server, and we can see that for some documents, from some query, for example, for the basketball with cartoon aliens query, we moved from all irrelevant documents to documents with the first one relevant. So the precision at 1, of course, got a perfect boost. And then we can see that from the version 1, we solved different problems, and we improved also the actors queries, so like the Patrick Stewart query and the one with multiple actors, for example. So it's not important at this point, of course, the specific queries and the specific documents in here, but it's important to understand the way you can explore the different iterations, the way you can explore the queries, because you may have like some topics, some queries performing very badly, and you're interested to explore a little bit why this happens, and you may want to explore as a software engineer the details of that. So effective, the documents that are currently being tuned and moved around in the search results, why this is happening, and then you may realize that a bug has been introduced, or simply your idea was actually beneficial. Okay, and this is the current state of the open source project. And let's go back to the slides. So I would like to thank you again, and if we have time for questions, probably.
Any questions? Thank you.
Thank you.
I'm going to walk the mic over if you have a question. Luckily wide aisles. Excuse me.
Thanks. Good stuff. I'm curious about what you hold constant and what you're able to change. So like under your versions, I saw some like Elastic server configuration stuff. But then it looked like other things like mappings were in a different section, maybe under fixed. So I'm curious, like as I'm going to explore space, of course you have to hold things constant. So what's your methodology for holding some things constant? What do you change? What are you able to change in your versioning system, and how do you manage that?
So the question is, what's currently possible to change in the configuration sets to then be able to assess the search system status. So ideally, if we have not missed anything, we should be able to actually tune everything that is currently tunable in Elasticsearch or Apache Solr to give the possibility of effectively reproduce a full system status. So as far as I know, we are covering that quite well, but of course, in case someone notes that, for example, a specific kind of configuration is not currently supported, because we tended to do like index time configuration and query time configurations through the various aspects of them in both the search engines. So that's the current state. But if someone noticed, for example, that we missed something, and also the version, of course, of the system. So yeah, that's what we are currently aiming to, and that should be available. Everything that is tunable from the search system status side should be currently tunable in RRE.
In your content model, you had a hierarchy, evaluation, corpus, topic, query group, and query, and you mentioned that topic and query group were optional. Can you elaborate on how you use topic and how you use query group in the system?
Yes, definitely. So effectively, if you have the optional so the question is the hierarchical definition of the information need and ratings is currently supporting a hierarchical model through the definition of additional enrichment data to the query, such as the collection, the topic, and the query group. And how do we use them? So effectively, they are optional because they only enrich the way the results are going to be hierarchically modeled. So if you define the topic and you define the query group, you are going to be able to see the matrix results averaged over the children at that level in the hierarchy. So you may see the precision at 1 for specific queries and the average of all the queries under a specific query group at the query group level. Then, at the topic level, you will be able to see the matrix results average over all the query groups, children of that topic. So it's basically to give the possibility of like business owner, for example, of product owner that are not interested to the low level to see what happens at higher levels in the hierarchy.
So I think that's all the time we have for questions right now. It's 10:45, but do feel free to come up to Alessandro and regale him with your questions. Thank you, Alessandro.
Thank you.
It's very interesting.